Welcome, mathletes, to section 4.13, Polynomial Functions and Modeling. This is our third day in this section, and today is all about the data. So we're going to crunch some numbers. Let's look at vehicle fuel efficiency. If you wanted to get some sort of line of regression, if you wanted to kind of be able to predict where's this trend going, then you've got some options. You could do a quadratic regression, where you only have three terms like this, or you could go even better to get a cubic regression like this, or even better would be a quartic regression. And you can see here, if you have a quartic regression, that means you have the leading coefficient would be ax to the fourth, and you have all of these numbers to play with, to adjust, to get the curve just right. If you do only a quadratic regression, then you only have three letters to adjust to get the curve just right. More letters equals closer to what it is it means you can get closer to the data. Let me show you what I mean. Here, if you actually translate all this information to a table, you can type that table into Desmos. This is what you would actually have to type into Desmos. You add a table, and then you fill in the years since 2000. And remember, this is like the year 2016 is actually just the number 16 because it's years since 2000. 16, and then 35.5 is the mpg, the miles per gallon. And you can then even type in y1 is approximately ax1 to the fourth, bx1 third, plus cx1 squared, plus dx1 plus f, and it'll give you a curve. And the curves are all going to be, they're going to go through the data through these points. The one that I'm drawing right now will basically go like this. Now, the coefficient of determination, the r-squared value, is going to get better and better. It's going to get closer and closer to 1 the more letters you have, because the curves are actually going to get closer. If you could somehow find data that was perfectly on a curve, then this would be equal to 1, like 100%. However, it's a little bit off. The curve is only slightly off here, but it's even more off for the cubic regression. And I'd like you to find the regression for the quadratic. So what you'd have to type in is y1 is equal to ax1 squared plus bx1 plus c, and see how closely a parabola will get. I've done the quartic regression, and what I had to type in was this. I want you to type in what you would need for a quadratic regression, and then see what the r-squared value is. And so you can see here in Desmos, you can, let me just go to projector mode. And so you can see here in Desmos, you can type in, you can add a table, you can type in the values that you have, and you can see here, they all fall along a curve. And then you can type out y1 is approximately ax1 to the fourth plus bx1 to the third plus cx1 squared plus dx1 plus f, skipping e because e is a special number. You can see, I won't even show you what e is. E is this 2.718, so you don't want to use e because it's a special number stored in, very much like pi. Pi, e, very similar concepts. So you can't use e in your function. Okay, so it gives you this quartic curve, and with these constants a, b, c, d, and f, and here they are. So if you wanted to, you could say that a new function g of x is actually 100% equal to ax to the fourth plus bx cubed plus cx squared plus dx plus f. And then if you wanted to come up with a prediction, all you have to do is type in I want 17 years, and that would be 36.459. So go ahead in your table right now, fill in, like on paper, fill in 36.459, or maybe just round it to the nearest tenth, 36.5 miles per gallon. And that's how you make a prediction. I want you to make a prediction for 11 years. What would go in between 10 and 12? So that's how you get a prediction for the year 17 years since 2000. I'd like you to do the same thing for 11 years. It would fit somewhere right here on the table. In fact, here you can see that if you make just a visual prediction, it would somewhere be in between 22.5 and 29.2. I want you to actually predict using the function in the same way that I did 17 years. I want you to find the prediction. And once you've done that, then you can head to Madrid, Spain, where I've been. Maybe you've been too. If you've ever been to Madrid, share me your stories. Otherwise, you can start 4A3 and then copy the problem list and do the first problem. I'll see you in